Some of our capabilities, as I said, for the most part, there are things like RF subsystems, multiplexers, switches, that sort of thing, and antennas as well. We're also very big in terms of scientific instrumentation, so there's an image of MOPITT there, and payloads, scientific payloads on various spacecraft. So some of the things that we're involved in terms of science payloads, we've done astronomical work, we've done fine guidance sensors. Again, this is sort of an optics and star tracker heritage. So for example, ComDev did the fine guidance sensors for the FUSE mission, the Far Ultraviolet Spectral Explorer. Space exploration is a little bit new to us, but we expect this to be a growing area, in particular things like closed loop life support and automation systems for things like surface mobility, unmanned or robotic exploration activities. Space situational awareness is something that's really big, both for our Department of Defense and for the Americans and for others. Basically, to know what's happening in orbit around the Earth, both in terms of active and passive, basically all RSOs, resident space objects. What's out there, where are they going, and do they pose a threat to our operational assets? And things like the collision of the Iridium satellite with that dead Russian booster and the shoot down by the Chinese of one of their satellites and the space debris problems. Again, this is something that's really coming to the fore in the last couple of years. Search and rescue, I'll talk about that a little later as well. Talked about MOPITT, and MOPITT was launched in December of 1999, became operational in early 2000, again aboard the Terra EOS-1 spacecraft, one of 6 payloads, this one being dedicated to carbon monoxide concentrations in the lower atmosphere. If you're ever interested in a really cool talk, I really recommend you guys invite Jim Drummond in from Dalhousie. He's got some really cool animations of MOPITT data. You can see basically, when they're burning the rainforest in Brazil or something, like you can see the CO just bloom and then recess as the seasons change. It's really cool stuff. And it's lived way past its warranty date. So it's been going on 10 years now in orbit and not listed B. And it's the only dedicated CO sensor that's up in orbit right now. So we're really pleased that MOPITT's still going. Search and rescue. There's a very interesting program that a lot of people don't know about. It's called COSPAS SARSAT. SARSAT stands for Search and Rescue Satellite, and COSPAS is the Russian acronym equivalent. And this was actually one of the earliest examples of US-Russian space cooperation. So it came about in the 1970s during a lull of détente in the Cold War. And the idea is that on some American satellites, usually they're NOAA polar orbiters, and some Russian satellites, they would put receivers and repeaters that would be able to detect the emergency locator beacons of the signals from, for example, downed aircraft or ships in distress, relay them to search and rescue authorities on the ground. And this is, again, one of these quiet programs that nobody ever seems to know about or read about in the news, but it's been tremendously successful, and without a doubt, tens of thousands of lives have been saved by this program in the 30 years since its inception. And since its inception, it's grown beyond the United States and Russia. So now Canada is involved in this in a big way in terms of providing these repeaters through our Department of National Defense to the American satellites. So our heritage product is the LEO-SAR receiver. LEO is low Earth orbit, so these are satellites, say, up to about 700, 800, 900 kilometers up, usually in polar orbit. The NOAA weather satellites are the general host for these. And for the next generation is what's called a MEOSAR, so this is a medium Earth orbit search and rescue repeater. And this will fly on the next generation of global navigation satellite systems. So it'll fly on GPS Block 3, as that's being deployed over the next couple of years, and the European Galileo constellation, if and when they get their act together. I have to be careful, but you know, just simple RF theory, it's obviously a lot more challenging to measure, to get a signal from 12,000 kilometers altitude as opposed to 700, 800, 900. But the benefits are you get wider coverage. So there's an interest in populating MEO with these repeaters as well. I talked about space situational awareness, so the big project, and we're collaborating with MDA on this one. MDA is the prime contractor for the Sapphire mission, and ComDev is providing the optical payload through our electro-optics division up in Ottawa. So this is the space situational awareness. Basically, it's a telescope not for looking at the stars of the solar system, but to examine other resident space objects and categorize, characterize, and track them. This is a, you know, again, really big interest on the part of militaries around the world, including our own Department of National Defense. JWST, James Webb Space Telescope. I said this is something that we're particularly proud of. This is a huge project, huge international project led by NASA with the European Space Agency and Canada. So this is going to be out, it won't be in low Earth orbit like the Hubble Space Telescope. It's going to be out at Earth-Moon L2, I believe it is. And it's going to be looking at the near infrared, so it's not an optical imager. Canada's contribution is the FGS, the Fine Guidance Sensor. And again, this is an indication of the level of trust that NASA has in Canada and the Canadian Space Agency and the ComDev. So this is actually the instrument that locks onto guide stars and points the rest of the telescope to enable it to do science observations. And if this piece of technology fails, then the whole mission fails. And unlike the Hubble Space Telescope, because it's out at Earth-Moon L2, there's no feasibility currently for any kind of human servicing. There were plans to put a docking ring on it to allow an Orion spacecraft to perhaps rendezvous or do something with it. With all the uncertainties in the Constellation program, we're not sure that that's going to happen. So, as far as anybody's concerned, this is like a fire and forget thing. So it really has to work when it gets out there. And I was up in Ottawa at the David Florida Lab back in February. So the David Florida Lab is the Canadian Space Agency's environmental testing facility, and I had the privilege of seeing the engineering model of the Fine Guidance Sensor going in for cryo and TVAC, thermal vacuum testing. So, this is something that's designed, and it will be launched at room-like temperature. But getting out into deep space, you're at about 6 or 7 Kelvin. Things start shrinking down. So the precision optics basically have to shrink down to the alignment that you need at that temperature in order to achieve the mission. So it's really a testimonial to some really fine electromechanical, thermal, and optical engineering that this is possible. I'll close off with one of the brand spanking new things that we're doing at ComDev, and this is what I'm involved in. I'm actually the business development manager for this new group, which is the MDG. I always got that confused with Miller. I don't know, I was thinking beer at one point, Miller Genuine. No, it's Mission Development Group, and it's the new microsatellite and nanosatellite mission group at ComDev. So basically a soup to nuts house where we find requirements, find customers, design missions for them, procure the spacecraft or build the spacecraft, as the case may be, integrate with the payload, and launch and then operate these missions to end of life. That's actually our new building in Cambridge. So this is actually a completely separate facility from the rest of ComDev. We're in the process of kitting out the assembly, integration, and test lab. So that humongous liquid nitrogen tank was put in about 2 weeks ago.